kernel module. And okay, the reason really I'm giving this talk is that lots of people seem to think that kernel modules are still something obscure, which they're not. And also with FreeBSD, okay, the application of the fun and games that we're going to have with the FreeBSD kernel module is to use them to alter the perception the user has of his system. So basically, as most of you will know, like all the information you get from the kernel, whether it's you're like looking at your file system or your process list or your network connections, you send a query to the kernel basically, and the kernel will then give you information about this. So we're going to use kernel modules and some other techniques to alter this information as it is passed to the user. The thing with FreeBSD is that it has secure levels which will prevent people from loading kernel modules if the secure level is higher. But there have been several kernel exploits in the last year that will allow users to lower that secure level. So it's not actually that far out as some people seem to think. Okay, short overview about what I'm going to do. I'm first going to very quickly look at some useful functions you can use in your kernel module. Then I'm going to look at some common techniques you can employ to alter stuff in the kernel. And then I'm going to make some examples, like common applications. And then I'll also say something about patching the kernel directly, so without the help of kernel modules. And then I'm going to look at some symbol table modifications. And at the end, about defending yourself against this stuff. Okay, some useful functions. What you probably want to do is copy memory from user space to kernel space. Because, say that this is called like arguments are passing, or you want to copy something back and forth. There's some functions that allow you to copy larger chunks of memory, which is copy in, copy out, copy in string, copy out string. There's a man page about this man line copy where you can find more information. And if you want to transfer smaller amounts of memory, like bytes or word size, you can use fetch and store. Then what you might want to do if you change more things when you load your module, or also if your module is manipulate interrupt priorities, so you can prevent an interrupt with a certain priority from being run, like for example, network interrupts while you're changing network code and stuff. Then also goes in the same direction, locking. There's a function called NGR, which is used in various places. You'll see it in the examples. And then dealing with user space memory, sometimes you want to like change, for example, the memory size of the current process. You can do it with the nmap file. And there's also lots of other the nmap functions, but you can find those also in the kernel source. Then something else that's really useful to look at before you start playing with this stuff is the list macros as they are defined in sysq.h. Because then if you go through the kernel code, you will see what's going on. And it's actually quite useful to use them to prevent mistakes and so on. Okay, techniques. Probably the most common technique is to replace function pointers in the kernel. Say, for example, in the syscall table, there's say you want to open a file in your program. You use the open syscall, and in the syscall table, there's an entry which says which kernel function to call for this open. And of course, you can then use this table to alter this entry to point to your own function, and then do some modifications before you actually call the real open. The same technique applies to lots of other tables in the kernel. For example, INET-SW, which records which functions, input and output functions to call for certain network protocols. Like for example, ICP input, ICP output. And you can also change this to point to your own stuff. Then there's also some single function pointers, like for example, IPFW, CTL pointers, which points to the firewall control function. So like, say when you want to add a firewall rule, this function will be called. Then you can modify kernel lists. You can there's basically two things you can do. You can either change the list as it is in the kernel, or you can cut out things off the list when they're given back to the user. For this you can use the list macros, and some examples include the all prop, which includes, which is like a list of all processes that are running on the system. You probably don't want to change that as it is used for scheduling, unless you want to like rewrite huge parts of the kernel. Another example is linker files, which will contain all the files that are being loaded. Basically your kernel file, also the file that will contain your modules. Another example is IPFW chainhead, which is like the pointer to the list of all firewalls here configured. There's lots more examples. If you look in the kernel code, you'll have a hard time not finding them. Then some techniques that I'm going to use later with patching the kernel is reading and writing kernel memory. For these, you probably first of all want to find out where a certain symbol is defined, like say where in kernel memory do I find the code for open, for example. You can do that with the KVM list, and then you can use some other of the KVM functions like KVM read and write to actually change the data there. Okay. Common applications. Probably the most common applications are hiding and redirecting files. So like say when a user, you have files installed on another machine and you want to hide them from the actual sysadmin, then basically when it does an ls, so it tries to open your file, you'll redirect that to your own function, track that, and see, do I want to hide this file? Yes, then return file not found, otherwise open it. Hiding processes, well, not much to say about that. Then hiding network connections, like say, if someone does a net stat on that machine, you can alter the output to hide your own connection. Same goes for firewall roles and network triggers, for example. Say a certain packet comes in, like ICMP packet, and it's a certain payload, you can trap that in your own function and do things. Hiding the module itself. I mean, it doesn't make much sense to do all this stuff when your module is right there in plain view. I mean, there's many more applications like hiding promiscuous mode of an interface, or like adding a syscall to allow you to sue without a password. I mean, there's lots of stuff. Basically, just what you want to do, you can pretty much do it. Okay, replacing system calls. This is like probably a more simple example. Like, if you want to hide a file, you can either replace the system calls as they're in the system call table, like I said, like open. If someone wants to open your file, stat, for example. If someone wants to find more information about your file. Git your entries if someone requested a listing of the current directory. You can also do it at level lower. Like all the file systems actually have a table which records which functions will be called for that particular file system. So for example, you can replace UFS lookup. This probably saves you a lot of time, because if you replace all the system calls, you have to replace every call that will in the end do a lookup, like open, stat, change, more, challenge, whatever. Yeah, then read here. Also, for example, procfs read here, like when you want to hide a certain process ID from procfs, you can catch that. Okay, I'm going to make a small example. I guess it's quite simple actually. Okay, there's different things you can do. You can either replace the whole function with your own stuff. You can first make a check and then call the original function, or you can call the original function and then later do some post-processing on the output. This is a simple example where you do call the original function. So this is the new UFS lookup function. Okay, in this case, just the file name is used to determine if the file should be hidden. So say file hidden says, yeah, all files starting with foobar will be hidden. And yeah, what this does is also check if you're the magic user. Like if you have a special user ID like yourself, you can still see the file. And if the file should be hidden, then the file not found will be returned right away. Otherwise, we call the old lookup function. When you can replace the function pointers when the module is loaded. So when you do a mod load, you'll replace the old function in the Bino table entry. And if you unload, you can also turn it back if you want to. I'm not going to say much about hiding processes because that's actually quite like hiding network connections. If you want to write something like this, you always have to ask yourself, where does this data actually come from? When I make this request, where does it come from? Where do I have to change things? And in the case of, say, netstat, this is actually a sysctl with the following MRD, like a ctlnet, and in this case, it's just for TCP. And basically, if you do netstat, a sysctl with that lib will be done. So basically, the function you have to replace here is sysctl. Okay. So replace sysctl in the syscall table. Write a new sysctl that calls the old one. And in this case, first call the old one, and then later filter out the entries and the connections that you don't want to be displayed. Yeah, I mean, there's if you write such modules, you in this case have to keep track of some what these undesired entries actually are. In the example code that goes with this, it's just a small list which records what you displayed. Okay, another thing you can do is hide firewall rules. Again, you can ask yourself, where does this come from? Like I already said before, there's a list in the kernel which contains all these firewall rules. So basically, if the packet comes in, this is checked against this list of rules. I mean, you could do and replace all firewall functions and keep a separate list for your own rules. But what you can also do is replace the IPFW CTL function that will display the rules, and add a flag for all the rules you don't want to be displayed unless I'm a Mac user. Yeah, like I already said before, requests for a rule list go to the function that is pointed to by IPFW CTL pointer. So you can basically just change that pointer to point to your own function that you load in module. And in this case, what you want to replace is IPFW get, which requests a list of all rules that are on the system. Yeah. So you can ask yourself, where can I hide? Where can I add? Where do you add this flag? Like every firewall rule is of struct IPFW, and there's actually already a flag entry there. So all you have to do is add a special flag, say IPFW FTNM. And then in your control stuff, set this flag for the rules you want to run. Okay, so basically when the module is loaded, you replace the old, in this case, you may record what the old function was. And you set the function pointer to point to your own function. If you record the old function, what I did in the example code is just check if it's an IPFW get, and in this case I do my own stuff, otherwise I just call the original function. Okay, if you want I can do a small example of that. I don't know, let's just add something.
Coming up to the trail and getting started to take, we'll take now and we'll take.
Let's say we divert all TCP traffic to port 999. So you see there we have now a rule 100. Okay, what I did here was maybe a bit faster. There's okay, I packaged this all up under a bit weird name maybe. And there's a function called CI CTL. And with this, you can ask the magic user hide firewall rules, and as you can see up there, they're gone from display. Okay. Like I said before, another thing you can do is rewrite the network input and output functions. For example, ICP input. I mean, you can do a lot of other stuff. inet SW contains all this information, you can just replace it there. So, say in this example, you would probably put that in like modload when you load the module. You replace the entry for the ICP protocol, and maybe the input function you point to your own function. I mean, you could do lots of stuff with that. I mean, you can make triggers, or you could say alter packets that pass in between and change them back to normal before calling the original input function. Say if you want to evade some stuff that's listening and things. Okay, hiding the modules. Like I've already said, all files that will be recorded in it is called linker files. And there's also a modules list. Like there's a difference between the module list and the linker files because every link file can actually contain multiple modules. So basically what you want to do is remove yourself from the linker files and also from the modules list. And in this case you also want to change the reference count on the original kernel file that the module will be with. And also the counters next legend of next, which are for the next linker file of the next module. Like that's the number you also see with KB and KLE stack. Okay. You don't necessarily have to alter tables or load a module to change the functionality of the kernel. What you can also do is just, if you still load a module with your own system calls, and then write a jump to the old function, so it jumps to your function and the function gets called. I mean, this means that you don't have to alter any tables, which gets interesting later when we're going to talk about defending yourself. You can check for the integrity of those tables. And then, of course, you can replace kernel code directly and not bother with it. Okay. What you do then, there's also a small example utility with the stuff I'm showing later. You find out the address of the old and new function after you loaded the module. So say you have open and you have pure open. And then you use a KB endlist to find the address of the old open and the new open, and then you write the jump to the old function to jump to the address of the new actual. Well, not too complex, I guess. Okay, you can also alter kernel code directly, and I'm just going to make a small example to show that this is actually not that obscure. I mean, the problem with all of this is that if you actually do this, then your patch will be highly version specific and highly compiler specific, so it will not be very portable. But still, it's kind of cool. Okay, I'm going to make a small example, maybe using suser. I mean, suser is used in the freebsd kernel to determine if you're the super user. And basically what this does is checks if you have UI user ID 0 or if you're like in the right geo. So you can change this function to allow another super user named you. So this means that you don't have to become root anymore to open raw sockets or all those kinds of things, because all these checks are not in the kernel, so you don't have to actually SU or anything anymore. Okay, first of all, suser calls suser xxx. And well, let's just look at the beginning of that function. First, there's some general sanity check being done. Say if I'm pointing to correct and proc are not defined, then it will print think on your screen. Then later it will do some other checks, and then at the bottom here it checks if you are user ID 0. Okay. Now if you replace kernel code that already exists, if you do things in an existing function, you kind of want to confine that to the space you already have there. So you have to find some form of place to add your code. So in this case, I mean, what comes to mind is to replace the think. Because, I mean, this is probably added as some general sanity check if someone is actually programming in the kernel and actually makes a mistake calling that as user XXX. So let's just assume that no one will miss a think on their screen. Okay. You can use, now you can look like, what does this look when it gets compiled? You can first find the address, start address of the symbol you want to change here as user XXX. You can do that using nm or the kvm functions. And you can use the object dump to find out, to disassemble the kernel at that place. Okay, so let's look at what does this think, what does it get compiled to? Yeah, it first was the printf, so you have a push, and then it calls printf, and then it does basically it sets the eperm that it will return the permission denied, and it will jump to the end and thereby return eperm to the calling function. And below you see what is done to test for user ID 0. And actually, if you maybe go back. All these, there are several return permission denied in this code, and if you actually look at the whole, compile function, which I didn't include here because it's rather long, then you can actually see that the compiler made it in such a way that all the permission denies will jump to the same address. And this is actually done here. At the end, if the user is not the super user, so jump is not equal, then it will jump to where permission denied is set. So basically there's not two things. Basically what you want to do is add another test. So you want to change, after the user ID 0, you want to change this to jump to a place where you can test if you're also the super user. And in this case you can change the jump below to jump where the printf is, and then cut out the printf and put your own code in it. Okay, so we're going to change the printf. First of all, you can, I mean, it's really simple, that's just an example. You will just jump over the following two statements if you're in a normal path of execution. Then you compare, you check if this is not maybe the magic user. If it is, then just jump to the end, so don't return the permission denied, otherwise it just becomes permission denied again. And then you replace the jump after the original user ID 0 test to jump to the compare statement. Okay. What's also kind of interesting is reboot proofing, because say if someone would not reboot the machine, then everything in kernel memory would be lost and your module would be gone. I mean, the first two for the modules are just some suggestions because I didn't try them. Actually, when the files in user local, etc. RCD are loaded, this is before the secure level gets raised. So if you like, because some packages also load kernel modules like the Ember and stuff. So you could put just a script in there which loads your module, and then hide that after it's loaded. And then the secure level will be raised, but you'll be there, so it's not important. Some other techniques that I've seen other people use is like say use an existing module, put your own stuff there, and then use a file direction later to run it. Then the stuff I've used, say for suser XXX, is at the same time that you change the code in kernel memory, you could have also just write the same stuff to /kernel and it'll just stay there. Okay, that's more experimental stuff which I did lately. You can also change the symbol table. Say if you if you know, like I said, want to find out where in kernel memory do I have open, where do I have get my the entries. This is also just information kept by the kernel, and if you read from kernel memory, you query that information, so you can change that also. Which becomes interesting later also when you talk about defending yourself. Every linked file basically comes with its own symbol table. And yeah, I'm not going to go too much into that, but in the example code that comes with it, you can have a look at how to do this. Okay, defending yourself. I mean, you can go through the syscall table and check its integrity also on the tables. So you can load a trap module that will trap the KLD load, or you can retrieve the kernel data yourself from dev kernel. Okay, checking syscall table integrity. What you should probably do there is load that module at startup, save a copy of the original syscall table or any other table you want to verify later. And then maybe add your own syscall, which will then just compare those two lists. If they're equal, then everything's cool. Otherwise, something bad is going on. The problem with this is that it can be found and defeated. If I'm the attacker and I know that this stuff is there, then I can just replace it also, or change what it has recorded, and then it will still think everything's fine. Also, the problem is that not all observations actually touch any call tables. Say, for example, if you write jobs to your own functions, or if you add kernel code, then none of these tables will ever be changed. Another way you can use is actually look into dev kmap and see if retrieve the symbol table from kernel memory there and see if any changes have been made. The problem with this is really that because we can now change the symbol table, we can actually set, say if I look at the syscall table entry open, does it go to open? Yes or no? If you can change the symbol table, you can change the value for open that it will find, so it will still think everything is fine. We can okay. As you can see now, it will look at the syscall structure sysend and see that the entry there is wrong. Okay, I put the syscall stable stuff in a different menu because it was just playing with it. So we now set the new address for open. And yeah, my tools are not very user-friendly, I guess. Alright. We now set a new address for open. So it will retrieve the address for open and it matches with the entry in the syscall table, so it will still think everything is fine. So I mean, this method doesn't work either. So using this kind of method is actually quite tricky. So you would actually maybe load a module that does the compare of the table, and then also hide that module, and basically use the same techniques as if you're attacking the system to defend yourself. Then another method is loading a trap module, trapping KLD load. And then you can say log if someone loaded a module, or deny module calls, or have some form of authentication on module runs. The problem is that you can find this just like you could find other syscom table modifications. Say now we checked for open. I can also check as the attacker if KLV load actually points to the correct function. And even if you change the symbol table also, you will still see that the address is much higher than the addresses of the functions that are in /kernel. So you will see that this is not the original function. And the tool, what it can also do is just rewrite it to point to the original function. And then you can still load your module, and then later you can restore the pointer to the trap module. And you can load a module without authentication or denial, or having it being loaded. Another thing you can do is retrieve the kernel data yourself. Say like the process list or the network connection list. I mean, it's in the kernel. In the process list, for example, it's very unlikely someone will change the actual list, otherwise you'd have to rewrite all the scheduling stuff, so it is there. So you can either write a special syscall to give you access to that data, or you can just read it from the daemon. Right, there's an example in the example code package as well. I don't know how my time is actually. I mean, basically, with all this kind of stuff, I mean, it's a cat and mouse game. You can get more and more obscure in attacking the system and writing kernel code everywhere. Or, I mean, if I'm a defender and I know what method you're using, most likely I can do something against it and find you. If I'm the attacker and I know what the defender is doing, and I can write to kernel memory, then it's the same thing. So basically, it's some kind of obscurity contest. And I mean, it's very hard. I mean, you could probably go on forever and spend the rest of your life writing obscure kernel functions. But that's not the point, I guess. Again, like I said, all example code for this article is available at the URL up there. And I also wrote a small article that outlines a bit more also about the stuff that I skipped now. No, actually not, because I just copied it up there. I'll add a link later when I remember it. Yeah, also, like if you've never programmed any kernel modules before, there's a really nice article by Andrew Reiter, which is called The Dynamic Maker of Facility Programming Tutorial. And if you're interested in like some of the exploits that lower the secure level, there's an article by kernelfun. Let me see. Okay. And there's also a paper about attacking previously with kernel modules, the system call approach that deals with only replacing system calls. But it's very interesting. Yeah, I didn't change the URL yet. It's also available at the GC website, but I wasn't able to find the URL this morning. I'm sorry. Okay, if anyone has any questions, yeah?
How does loading a module in FreeBSD actually work? Is the EF loader in the user space or is it not space?
It is in the kernel, I think.
Well, the question is actually, can you write a worm payload that doesn't touch the disk and knows the module?
You probably could, but I'm not a payload person.
Not just a size question, because on Linux you have to have the EF loader in user space, this kind of thing. Or at least you have to pass the kernel tables to get the relocation done in user space. So it's kind of you can write a store payload that doesn't.
Yeah, I'll have to check on that. Okay, no questions? Yeah? Well, you don't need a compiler installed on a target machine. If you have a FreeBSD machine at home, you can just compile it there. I don't know, I looked at some 4.2 stable later and some recent 4.3 and there was not any difference. But I expect this to be different at some point. Yeah. But I mean, you can always check if it's still the same before you do this. That would be good. Yeah.
If we apply those, the last class change,
Could be.
in addition to the units and process stuff. As for loading stuff without a kernel loader, you get that memo that came in heads of things.
Yeah.
And sometimes it's just easier to overwrite a function, get that function called, and use that as a loading for the program. I work with JVM before DC.
Okay. Great. Any other questions? Okay.